The Intermediate Value Theorem, abbreviated as IVT, establishes a crucial consequence of continuity on a closed interval. It guarantees that a continuous function takes on every value between its endpoints, ensuring no jumps can skip intermediate values. Here is the formal statement. If f is continuous on the closed interval a, b, and n is any real number between f, a, and f, b, then there exists at least one number c in the open interval, a, b, such that f c equals n. The theorem has three key conditions. First, continuity on the closed interval a, b, f must be continuous at every point in the interval, including the endpoints. Second, a closed interval, meaning the domain must include the endpoints a and b. Third, n must be between the endpoints. N must satisfy the minimum of fa and fb less than or equal to n, which is less than or equal to the maximum of fa and fb. One important implication is the existence of roots. If fa and fb have opposite signs, so for example fa is less than 0 and fb is greater than 0 or vice versa, then n equals 0 must lie between them. By the intermediate value theorem, there exists some c in a, b where fc equals 0, meaning we have found a root. Another implication is range coverage. The function achieves every value between fa and fb at least once. Let's look at an example. Consider the function fx equals x cubed minus x plus 1 on the interval from -2 to 2. At x equals -2, f minus 2 equals -8 plus 2 plus 1 equals -5, which is less than 0. At x equals 2, f2 equals 8 minus 2 plus 1 equals 7, which is greater than 0. Since f is continuous everywhere, being a polynomial. The intermediate value theorem guarantees at least one root in the interval from -2 to 2. There are some important notes to remember. The intermediate value theorem is non-constructive. It confirms that a value c exists but does not provide a method to find it. Also, the theorem can fail without continuity. If f has a discontinuity such as a jump discontinuity, the IVT may fail. For instance, consider the floor function fx equals floor x on the interval 0, 2. This function skips all values in the interval 0, 1 despite f0 equals 0 and f2 equals 2. Finally, the theorem ensures at least one solution, but multiple solutions may exist, for example with oscillating functions. Finally, the connection to continuity. Continuity, defined rigorously using limits, underpins the intermediate value theorem. If the limit of fx as x approaches c equals f, c holds for all c in the closed interval a, b, the function cannot leap over values between the endpoints. This video about intermediate value theorem is part of our larger Calculus 1 for Engineering Students course. The course is entirely free and has more than 100 subtopics inside it. We're excited for you to try it, and the link is in the description.